All right, everyone, welcome back to the land of Chem. I am your host and the author. My name is Jeffrey Drum. Thank you all so much for joining me again.
All right, everyone, welcome back. Now, today, the heavily requested and highly anticipated full breakdown and analysis of the new synthetic aperture radar CAFRA project team data presented at the recent conference in Malta. Ladies and gentlemen, as always, thank you all so much for your support. I think that's it for today's intro. So without further ado, let's get right to it. All right, everyone, here we go with tonight's episode. Now, to begin, if you're new to the channel, to the topic of SAR scanning, or just want to get caught up on my assessment thereof thus far, I highly recommend starting with episode 60, covering their first paper presenting scans of the Great Pyramid of Giza from back in 2022. Episode 153, discussing the initial release of data from their Central Pyramid scanning project, and episode 162, the full conference footage from their recent Malta presentation, links in the video description below. And like I said in all of these videos, I am excited, enthusiastic, but skeptical about the data that has been released by the team. And this video, much like the previous, is not intended as a debunking, nor is it in support of any conclusions proposed by the CAFRA project. Rather, my goal here is simply to explain the new information that was presented during the Malta conference and offer my honest and objective interpretation, which will include both positive and negative feedback. Since meeting Armando and Filippo at the conference, we have been in direct contact, and everything that I will say in this video are issues that I have discussed with them in person, not only with my questions and objections during the conference, but also in recent personal communication. And like I've said before, I really like these guys, and I believe that what they are attempting to do is incredibly important, which is implementing new technology for independent investigation of the Egyptian pyramids. But with any groundbreaking claims, it requires even more evidence. I will say that it takes courage to stick your neck out there and risk your reputation by trying to do something extremely controversial and revolutionary. And I commend them, and I have the utmost respect for the team for doing so. For example, my hypothesis that the Egyptian pyramids are for industrial scale chemical manufacturing is one that will require a lifetime of research to substantiate. I have already written one book with a second on the way, and I've produced almost 400 videos supporting my ideas. But this is just the tip of the iceberg of what will inevitably be a lifetime of work required to justify this proposal. This SAR team is in the same boat. They should be prepared for the long haul to try and prove these claims. And after meeting with them, I do feel that they truly believe in what they're doing, and they will continue to pursue both academic and alternative acceptance of their data. So with that being said, let's jump into the presentation, and I'll break the whole thing down step by step. First, a brief explanation of how the technology works, showing here how the original satellite data is compressed with the surface target object here, the initial data here, the range compression into this, the range interpolation into this, and the azimuth compression into this. And after the process is complete, we are left here with the image of the target object. And I will refer to this compression sequence later on in the episode. Next, an explanation of their phonon technology. Essentially, they have developed software that enables the detection of surface microvibrations and resonance signatures that emanate from various components inside of the structure that differ from the surrounding environment. The variations in these surface resonant phonon signatures is what provides the indication of internal chambers or other structures embedded within the target object. Okay, now they move on to a critical part of the presentation, which is proof of concept, with several examples of modern structures that were scanned to prove that their technology could detect known internal features, starting with the Carrowkeel tunnel, which they scanned, and they were able to show images of this tunnel running through the mountainside, as you can see here. Next, the Gran Sasso in Italy, a physics laboratory embedded into a mountain that has numerous tunnel features and also a machine known as an interferometer, a large piece of modern physics equipment that not only has significant power running through it, but it also produces mechanical vibrations while in operation. This will be relevant in the proof of concept evaluation at the end of the video. So they scanned the mountain and they were able to detect the primary tunnel and the area of the compound that houses the interferometer, as you can see here and reflected in the diagram here. The main tunnel, these components, and the interferometer area here, all shown in the diagram as accurately reflected in their scan data. A solid proof of concept demonstration for establishing the validity of this technology. Next, the Mosul Dam that you can see here, a structure that houses a number of turbines within the dam for the production of hydroelectric power. Again, an important distinction to make here is that in several of these proof of concepts, there are modern machines inside of these structures that were in operation during the scanning. They have power running through them and moving parts that produce mechanical vibrations. Again, coming up here at the end of the video. So they scanned the dam, which features both Kaplan turbines and Francis turbines, with the scan data here showing both the Kaplan turbines and the Francis turbines. A clear, vibrant, and accurate depiction of these internal components. And the last example in their establishment of proof of concept during the presentation for this technology by scanning modern structures to detect the known internal features, the Gotthard Tunnel, a huge tunnel that was excavated through an immense mountain. So they scanned the mountain and they were able to detect the tunnel running through the inside of this massive mountain. So these steps, establishing proof of concept, are absolutely critical. When it comes to the implementation of a new technology that has novel applications, such as discovering hidden chambers and deep underground structures, the novel applications will never be accepted until the basic functions are firmly established and proven time and time again. In this case, detecting the known, existing features within any given target object. And I have proposed a challenge and project to both Armando and Filippo that I think would be a huge step forward in establishing this proof of concept and the scientific validity of this technology, scanning the red pyramid and demonstrating, and here I'll use the terminology that they used in their first paper, quote, transparent like a crystal, end quote, demonstrate clear images of the 3 internal chambers within the red pyramid. And Armando and Filippo, if you guys are watching, for this project, let's take a step back and don't say anything about hidden chambers or underground structures. Establish the proof of concept for the technology by showing accurate, reliable, and repeatable images of the 3 known chambers. This process of introducing the new technology should involve 2 steps. First, stating the basic function. We have a new technology for scanning structures and showing internal components. And 2, here is our proof of concept, showing a variety of ancient structures with clear, accurate, reliable, and repeatable images of the known internal components. After this proof of concept has been firmly established, the technology can then be implemented for additional applications, for example, revealing potential hidden or unknown features of these structures. So scanning the Red Pyramid of Dashur would be a massive leap in showing that this technology is capable of detecting and revealing, again, using their language, quote, transparent like a crystal, end quote, the three known internal chambers of the structure. This proof of concept has to be done first before anything else can be considered. And this process is exactly what the SAR team was doing in the first part of this presentation by establishing proof of concept, scanning modern structures to show the known internal components. So this was a really important and fascinating part of the new conference data that added significant credibility to their recent discoveries. However, there are some issues with this proof of concept by scanning modern structures containing operational machines that produce mechanical vibrations that I'll discuss in just a moment. So now they move into their recent scans of the Osiris shaft, shown here, indicating that they may have detected the three levels of this subterranean system, and their scans do show three distinct features that seem to align with the three chamber levels of the Osiris shaft. However, one problem has already been presented by the channel Night Scarab in a recent post. And I will say Night Scarab does exceptionally detailed research, and I highly recommend the channel for more conventional interpretations and Egyptology research, which you can see here, where a scale diagram of the Osiris shaft was applied to the raw scan data, and the scans don't align with the actual measurements of the system. The first level is off by approximately 4 meters. So there is something odd about these scans that don't match exactly to the known configuration of what we have on the Giza plateau. Granted, these scans are taken by a satellite from space, so some leeway has to be taken into consideration, and that may possibly be what we are seeing here. But specifically regarding the known configuration on the Giza plateau, this signature to the left caught my attention. And I asked Filippo directly about this during the conference, and he said this, quote, "It must be something new," end quote. Okay, great. But according to the physical data and the archaeological research on the Giza plateau, there is nothing here to the left of the Osiris shaft. So for now, let's table that point, and I'll come back to it at the end of the video. I also pressed him about the water table, which you can see here, that is right at the bottom of the third level, and what is shown below the three chambers, which is this signature here in the middle. He indicated that this 1, 2, 3 are the known chambers of the Osiris shaft, and that this dark feature down here may be an unknown chamber feature, but there didn't seem to be any acknowledgement of this signature here in the middle, of being anything at all, even though this signature here looks a lot like the signature of the chambers at the top. So there's something about this scan that doesn't sit 100% right with me, given what we know about the water table, the known configuration and measurements of the Osiris shaft, and the physical evidence for whatever this is on the Giza plateau. I also asked Filippo if the readings of the scans could also be detecting materials of different density and composition, natural geological features that are somewhat different than the surrounding bedrock that produce a different phonon signature that is recognized by the satellite. And he said yes. So this scan data of the Osiris shaft is another tremendous step forward for the proof of concept process. However, there's also some issues with it. And as you'll see at the end of the video, we decided to hit the Giza plateau for ourselves in an on-site investigation of whatever this is here shown in their raw data. Next, on to the Great Pyramid. As you heard in the full conference video, I did not hold back when asking Filippo tough questions regarding the data. For example, in the image he is showing here, why isn't the radar detecting the known chambers, specifically the Grand Gallery? You can see here that there's a lot of signature over here, but nothing showing up detecting the Grand Gallery. This is the same image from their first 2022 paper. We have a slight signature here detecting the Queen's Chamber. This is good. However, there's nothing here showing the King's Chamber or here detecting the Grand Gallery. So my question was, quote, why is the satellite radar and data not showing the Grand Gallery, end quote. And his response was, I don't know. He mentioned that it may be a result of the tomographic line for that particular scan. In other words, the slice of the Great Pyramid that was being scanned, meaning the trajectory of the satellite as it scanned over a particular section within the Great Pyramid. Well, there is one issue with that explanation. As all of the chambers of the Great Pyramid are stacked directly on top of each other on the same north-south axis within the structure. They are all aligned in the same slice of the pyramid. So if your satellite is flying over the Great Pyramid over and over again, taking a scan of this tomographic line, it should be detecting all of the chambers, the King's Chamber, the Grand Gallery, the Queen's Chamber, and the subterranean chamber, because they are all on the exact same axis inside of the pyramid. But we don't see the King's Chamber here, we don't see the Grand Gallery, and we don't see any of the connecting shafts. To reiterate my previous point, establishing proof of concept with accurate, reliable, and repeatable detection of the known chambers is the most important thing. And I don't see this to be the case with any of their scans of the Great Pyramid. He did say that some of the scans show the Grand Gallery, but not all of them, and again, he didn't know why. Now I will say that I commend Filippo for his honesty, and it was a mark of integrity for a scientist to be able to admit when they don't have any specific answer. I actually gained a ton of respect for Filippo and Armando during this presentation because of how they responded to questions. And I'm not trying to be overly critical here, but in my opinion, this is a pretty major issue. I am certainly no expert in SAR technology, but I am an expert on the Egyptian pyramids. And if you say that your technology can detect hidden chambers and other unknown features, but it isn't showing the chambers that we know are there, this creates inherent skepticism about any other conclusions or discoveries that are presented. And unfortunately, this is not the only time we're going to see this issue come up. Another example here from their 2022 paper, scanning the Great Pyramid. The Queen's Chamber, that you can see down here at the bottom, seems to be easily detectable and presents in their raw data. But the King's Chamber doesn't appear as clear, with a lot of the signature, when you can see it here overlaid with the diagram, it seems to be outside of the chamber itself. And here on the next diagram, showing a better scan of the King's Chamber, it does appear to be detecting the horizontal red granite beams of the relieving chambers, but some of them are missing. For example, this one here and this one here isn't really detected. And there are horizontal signatures here and here, here and here, in the center of the chamber where there are no horizontal features that actually exist. Also, the chevron blocks at the top. as you can see here in the diagram, that are not present here in the raw scan data. This is another question I have about the ability of the technology to detect the known configuration. Next, the scan of the Sphinx. I actually thought this was pretty cool. You can see the Sphinx here overlaid with the raw scan data. But there's no differentiation in the raw scan data between the ground, the air, and the body of the Sphinx monument. All it shows is the signature here in the center, but the rest of the structure doesn't appear at all in the raw scan data. This, to me, seems unusual, but it may be just how the technology or the calibration thereof works with this particular scan. Next, moving to the inside of the Khafra pyramid. Several slides here showing the new data. And at this point, I think it's too early to say that these are hidden chambers. Are they detecting something? Yes. But as Filippo acknowledged to my question, it may also be core material of different density or composition. And here is the point where I asked him again the same question regarding the Great Pyramid. Why is their radar not detecting and showing in the raw data the two known chambers of the structure, which aren't shown in any of these images? And his answer once again was, I don't know. Now, here I have to point out something else. In a post from the Synthetic Aperture Radar team on their official Facebook page, stating here, and I'm going to quote this, detection issues related to the known structures inside the Pyramid of Khafra. Satellite data only reveal the entrance, the descending corridor, and the roof of the Belzoni chamber. This is because the structures are embedded in a limestone slab that absorbs the signal. First, let me clarify one detail. There is no, quote, limestone slab, end quote, below the central pyramid. The chambers of the central pyramid, the Khafra pyramid, are excavated directly from the limestone bedrock of the Giza plateau. This is a well-known and firmly established archaeological and architectural fact about these chambers. As you can see here in these original diagrams, all of these areas shown with rough marks are showing excavation directly from the bedrock. Like Armando's post says, the roof here and the upper descending passage are made from limestone masonry. That you can see here, again, the upper descending passage made from limestone masonry, and the roof of the Belzoni chamber here also made from limestone masonry. The rest of the entire system is excavated directly from the bedrock, no deeper than 15 meters, estimated at approximately 10 to 15 meters in the bedrock. So let me say this again, that these chambers are excavated directly from the limestone bedrock to a depth of no more than 15 meters. And I will now rephrase this explanation, giving the known details that I just explained. So detection issues related to the known chambers inside of the Khafra pyramid are because the radar signal is absorbed by the limestone bedrock. The radar signal is absorbed by limestone bedrock no more than 15 meters deep, and it cannot detect the chambers that are excavated into it. Let that sink in for just a minute. The radar signal is absorbed by limestone bedrock no more than 15 meters deep, and it cannot detect the known chambers that are excavated into it. And this isn't my opinion or commentary. This is a post coming directly from the Khafra Project SAR team explaining that the radar signal is being absorbed in this limestone bedrock. And for now, I'll leave it at that, as we look at the actual scan data of what they found inside of the central pyramid, which you can see here. And there's a specific reason why I'm not showing any of the models that were made of this raw data that illustrate the so-called Z chambers emulating the design of the King's Chamber of the Great Pyramid. Because according to their explanation, the models are not computer or AI generated. The SAR team made these models as an artistic expression and interpretation of what they see in the data. And at this point, we don't know what this is. So extrapolating from this raw data into a 3D model is simply their way to show the world what they see in these images. This could just be dense bedrock within the pyramid core that is giving a stronger signal than the surrounding material. And with all of that being said, let's take a look at some of the raw data showing what they discovered below the pyramid, presented in these slides here, here, and here. All right, everyone, I hope you're enjoying the video, and if you are interested in the ancient technology of a lost civilization utilizing physics and chemistry and the function of the Egyptian pyramids and other ancient structures from across the world, please remember to subscribe to the Land of Chem here on YouTube so you don't miss out on the new episodes that premiere twice per week. If you want to help support the channel, check out thelandofchem.com. You can pick up a copy of the book or grab some merch, link in the video description below. And if you want to get access to exclusive research videos, check out the Land of Chem members only channel, now up to 22 absolutely massive research episodes that also feature some unreleased expedition footage. Ladies and gentlemen, as always, thank you all so much for the support. Now, back to the video. All right, now, at this point in the video, I was going to provide my opinion from a technical standpoint about what is happening during this data compression process when the software is being calibrated to move from an object on the surface to a deep underground feature that produces these vertical signatures. However, out of respect for Armando and Filippo, and in acknowledgement of their expertise in this area, I've decided to leave that out. Like I said, I am not an expert in synthetic aperture radar technology, and I am not qualified to give any technical explanations or commentary. I am an expert on the pyramids, and if I see missing chambers or things that don't 100% match the known configurations, I'm going to point that out and highlight the issue as I've done in this video. But for now, I'm going to give them the benefit of the doubt, and I will wait to provide any further commentary on these pillar structures until we get a few things. First, a control scan of limestone bedrock that does not have any pyramids and is nowhere close to any pyramid sites. This will give us a basis of comparison by which we can evaluate the scan data. And second, until their formal paper has been published and all of the information has been released. I do have an interpretation, opinion, and some issues about what is being shown with these vertical signatures. But until I get a chance to speak more with Filippo and Armando directly and get more questions answered, I am not going to speculate on a very technical situation without additional clarification. Like I said at the beginning of the video, I like these guys, and I highly respect what they are doing. We need technology like this to better understand the Egyptian pyramids. Am I skeptical about the whole thing? Yes, absolutely. But I want to give them the opportunity to more firmly establish proof of concept and formally release all the data before being overly critical. Now, on to another topic that has been addressed, which is their representation of the water table, which, according to Filippo, is indicated on the raw data that you can see here, where the signal starts to fade. So this is above the water table. This line here is where the signal starts to fade, and all of this below here is below the water table. But this line is several hundred meters, approximately 300 meters below the surface of the Giza plateau. And as we know, in the Osiris shaft, the lower chamber hits the water table at 30 meters below ground. This issue was also discussed by friend of the channel Matt Simpson from Ancient Architects, where he presented studies showing the water table approximately 50 meters below the surface of the Giza plateau that you can see here. So there's a big difference and disconnect between the geophysical evidence of the Giza plateau water table studies and what is being shown here by the SAR team. Another good point made by Matt in his video, link in the video description below, is similar to what I just said regarding the control scan for us to compare this data. Like I said, go out in the middle of nowhere and scan some random limestone bedrock in Egypt and share the raw data so that we can see what it looks like hundreds of meters below an area where there are no pyramids, and show what the radar signal looks like when we scan these type of limestone bedrock areas. This will provide a solid basis of comparison. As with any other scientific experiments or examination, a control sample is evaluated against the experimental sample, and that's what we need to evaluate this vertical signature found below the pyramid structures. Now, something interesting that they also presented are recent scans of the deep vertical bedrock shafts, the raw data of which you can see here. And we know for sure, as you've seen in many of my Sunday site visits to Giza, that these vertical bedrock shafts at around 30 meters connect into horizontal transverse shafts going down the Giza plateau. And this is exactly what you can see, the vertical shaft here, and at around 30 meters, it connects into a horizontal feature here. However, they're also indicating that these shafts go much deeper into the plateau, approximately 200 meters. This scan is a bit different than the others because the shaft is not embedded or encased in limestone masonry or bedrock. It's just an open cavity for the satellite radar to image. And I can say from on-site experience that there are horizontal features like this that connect all of these deep vertical bedrock shafts. So this one definitely caught my attention as being potentially viable and accurate imaging of these bedrock pits. Now, the next two images are high-resolution scans shared by Filippo Biondi showing the features that they have recently discovered below the Menkaure pyramid, the final pyramid on the Giza plateau. You can see this vertical signature here. And also from their recent scans of the Sphinx, again, showing this very similar vertical feature here. And now, I'll reserve any further comment on these vertical structures, like I said before, until their full paper has been published and we have a control sample scan of some limestone bedrock that we can compare to these scans below the pyramid and Sphinx structures. And also, until I've had a chance to talk with them more in depth about the data compression process, because I do have some very technical questions that only these guys can answer. But let's go back to this slide from their first paper from 2020 and the scans of the Great Pyramid. And recently on Facebook, the SAR team has been showing that this scan also detects the newly discovered passageway on the north side of the Great Pyramid below the chevrons that you can see overlaid here. Well, again, I have some issues with this. The signature that they are indicating showing this passage, so remember this area here, the raw data signature extends all the way out of the pyramid, down into here, and up into here. This is all one giant signature here. And although it does overlap with the newly discovered passage here, the vast majority of this signature is not even inside the pyramid at all. The whole scan overlaid with the chamber images are not a good reflection of proof of concept to detect the known chambers within this given target image. Which brings me to another point. my rating of the SAR data regarding proof of concept to detect known internal structures. And I will say that I thought they did an exceptional job demonstrating the viability of their technology to detect known features inside of target objects. And I'll walk through each one of these step by step. First, the Carlin Tunnel. I looked at this scan over and over while making the video, and I just don't see a tunnel in the data. So I'm going to give this one a no. Next, the Gran Sasso. This one I thought was really good, and they were absolutely able to detect internal features. So this one gets a yes. Next, the Mosel Dam. Another exceptional imaging of the turbines inside the target object. So this one also gets a yes. Again, proof of concept detecting known internal structures. However, both of these examples, the Gran Sasso and the Mosel Dam, have to get thrown out of our evaluation process as they contain modern machinery in operation that is producing mechanical vibrations during the scanning process. These mechanical vibrations are exactly what this technology is designed to detect as surface phonon micro vibrations. And these do not apply to scanning ancient pyramids where there are just empty chambers and no modern mechanical equipment. So these two proof of concept examples were great, and they 100% were able to detect features deep inside of target objects. However, it doesn't apply to scanning for pyramid chambers where there are no moving parts or modern machines. So these two, they get striked out. Next, the Gotthard Tunnel. Yes, they scanned the mountain and they 100% absolutely showed the tunnel. Next, the Great Pyramid. Well, as you just saw in the raw data, no King's Chamber, no Grand Gallery, no connecting shafts. They did show the Queen's Chamber, but unfortunately for me, this one is a no in its ability to detect the known internal structures. And unfortunately, also a no for the Central Pyramid, as according to their own statement in that Facebook post, the satellite radar signal was absorbed by 15 meters of limestone bedrock, and they couldn't detect the two existing chambers. And the last one, the Osiris shaft. And I'm actually going to give this one a yes, and you will see why shortly. So this leaves us with a proof of concept reliability rating for detecting known internal features of any given target object of 40%. And this is about where I stand on the project overall. A 40% chance that this technology is showing something significant and real still hidden inside of the pyramids and below the Giza plateau, although these may end up being just normal geological features. So this, the reliability rating, is exactly why I propose projects like the Red Pyramid scanning. To take a step back from all this talk about underground cities and hidden chambers and giant pillars and show the world and the community that the technology can accurately, reliably, and repeatedly detect the three known chambers of the Red Pyramid and show the raw data. I have both privately and now publicly presented this challenge, and I don't think these guys care about my opinion, but coming back with more data, like scanning the Red Pyramid, that shows accurate imaging of these chambers would absolutely start to increase the trust in the technology to show us things that may still be hidden or unknown. So for now, again, in my opinion, this should be their main focus, getting control samples and scans from random areas of limestone bedrock and stacking up more and more of these proof of concept scans to show the known chambers of all the pyramids. The Red Pyramid, the Bent Pyramid, the Pyramid of Menkaure, the Pyramid of Wunis, the Step Pyramid, the Serapeum, and so on. Present more of these scans with no mention of hidden features, but in the process, establishing bulletproof proof of concept that this technology works to detect the known chambers. Then, Once this has been achieved, the additional applications of using this synthetic aperture radar scanning technology for finding hidden features can be implemented with vastly improved scientific and academic credibility. And for now, this will be my last video on the topic of these SAR scans, until a second formal paper has been published. I do believe that this technology and their project deserves the opportunity to prove itself, which it's going to take a lot of work, but I know that these guys are up to the task and they are doing everything that they can to establish the viability and trust in their technology, which brings me back to the scans of the Osiris shaft. And after seeing this raw data during their conference presentation, particularly this feature over here, I knew exactly what I was doing as soon as we returned from Malta, going back to the Giza plateau for an up-close examination of the area around the Osiris shaft to evaluate if there was any evidence of a hidden structure or feature to the left of the Osiris shaft. And I think you will be surprised at what we discovered. The full video coming up next in Sunday Site Visit 112. All right, everyone, that is it for today's video. This was episode 166, SAR Conference Data Breakdown. I really hope you enjoyed today's video, and in the next episode in the series, we will resume our discussion of the mechanisms of operation driving the ancient Egyptian pyramid chemical engineering technology with the function of the bent pyramid, part 1. This is an episode you do not want to miss, so if you haven't already, please subscribe to the Land of Chem here on YouTube. If you're interested in the technology of a lost civilization, utilizing physics and chemistry, and the function of the Egyptian pyramids and other ancient structures from across the world, remember to click that little notification bell so you don't miss out on the new episodes that premiere twice per week. Please like, comment, share, and stay tuned. If you want to help support the channel and get access to exclusive research content, check out the Land of Chem members only channel and thelandofchem.com. If you want to pick up a copy of the book or grab some merch, links in the video description below. If you want to follow me on Instagram or on X, my handle is @thelandofchem. Also, don't forget, after you finish watching this video, please go subscribe to our 3 other channels: Ancient Odysseys, Let's Go with Lex and G, and the best channel on YouTube, Egyptian Trash Cats, for all you cat lovers out there. Ladies and gentlemen, as always, thank you all so much for the support. I think that's it for today's episode. I will see you next time. Yo, are you still watching this? Please subscribe to the Land of Chem here on YouTube and click that little notification button. New videos coming out every single week. And check out this other episode. Come on, do it. Do it now.